Our first presenter is going to be Justin Sherrill. Is it working?
Mm-hmm.
Perfect. Okay, with transit access analysis in R.
Great. So great that there's a lot of you. I was hoping that there would be fewer. But yes, so my name is Justin Sherrill. I'm a senior analyst, technical manager at Echo Northwest. We're an economics and urban planning consultancy based out of Portland, Oregon. We have offices in Seattle and LA as well. And I just want to probably get right into it and present this very blandly titled transit access analysis in R. What I'm hoping I give you is just kind of like a demo of some packages that I think are really cool and a typical sort of analysis that I or others at Echo might do with them using these packages along with our typical packages like tidyverse and SF. So let's get right into it. Transit access is a really vague, denuded, jargony, plannery term. And what I really mean is transit usefulness. That is to say, how useful is transit at getting you from your home to your place of work, from your place of work to your doctor's office, to from your doctor's office to a park and back home, or any permutation thereof at any time of day, anywhere in your metro region. Typical sorts of people who would do this sort of analysis, as far as I know, mostly urban planners, people who work in public health, perhaps, developers who are interested in citing infrastructure, affordable housing, job sites, and the like. And really what you can do with this sort of analysis that I'm going to show is compare transit against other transport modes. Typically, that's going to be car. And in the US in this day and age, transit is struggling to compete against car transport. Or you can compare transit usefulness over time, from AM to PM on one day, from weekend compared to weekday transit, from 1 year to another. Hold on to that thought because that is what I will be showing later. As I mentioned before, all of this presentation is going to be written in tidyverse, SF for my spatial analytics, TidyCensus and Tigris. Big shout out to Kyle Walker for wrangling some demographic data and shape files, and MapView to make it all into some pretty maps here and there. But the real stars of the show are going to be these two packages, TidyTransit and R5R. And these are going to be the tools that you can use to interact, manipulate, and visualize GTFS data. I'll get to what that is in just a second. But really, just learning about transit schedules only gets you halfway. We need to know about the world. We need to know about amenities. And so we're going to use OpenStreetMap and pull some of that down with OSM data. Case study for this analysis is TriMet. How and where has TriMet service and usefulness changed between 2019 and 2023? Okay, and like I mentioned earlier, to answer that, there's really only two ingredients. GTFS, which is basically going to tell us where and when the buses are. Typically comes in the format of a zip file and that contains many other goodies inside of it. And OpenStreetMap is going to tell us where the streets and all the other stuff is. Basically, where the world is and where the transit is gives us transit access analysis. Okay, and this is all the static data that's being read in to this presentation. As you can see, here's my GTFS for CTran. That's the Vancouver, Washington transit network for those of you who don't take transit in Vancouver, Washington. And there's my TriMet GTFS for 2023, and I have versions for 2019 as well in another directory. Okay, GTFS, what is it? It stands for General Transit Feed Specification Relational Database. Basically, it was invented by TriMet IT staff along with some Google programmers in 2005. The impetus of it was that the IT staff were annoyed at having to kind of like totally go back and relearn every single other transit agency's way of storing their transit scheduled data in order to compare to TriMet's data. So they were like, there should be like a standard, there should be a lingua franca that we all use. And they came up with this. It's a big relational database because at the base of it, we all know that transit agencies typically share a lot of things in common. They are an agency. They have a network that is made up of routes. All of those routes make trips throughout the day. All of those trips make stops at stop times, and all of those stop times are at stops that have pertinent information, most importantly, where they are, X and Y coordinates. You link those all together with some join keys, as you can see here, and you come up with a template for transit agencies to basically share their transit data with entities such as Google. So if you ever planned a trip using Google Maps, using transit mode, congratulations, you've used GTFS data. So this is typically packaged seasonally by larger agencies. They go through a lot of transit schedule changes. Smaller, more rural agencies are only going to put out maybe one a year. Okay, where do you get it? As far as I know, there's 3 main sites that I go to. There's Transit Feeds, it's soon going to go away. It's going to get replaced by database.mobility.org. As you can see, you can go here. There's API. There's a list of every transit agency in the world that you can download their static GTFS zip files from, or you can call the API, and they store basically historic GTFS data, which is really great. Or if you don't find it on one of those, most transit agencies put it up directly on their website somewhere. Just Google it. Okay, OpenStreetMap, at least for getting to the street network data that we're going to need later. I typically use Interline, which is great for doing extracts of like metro areas. There's also GeoFabric, if any of you have used that. That can give you extracts for like entire states, entire countries, if you have the hard drive space for it. Okay. Let's start answering the question. I'm going to use tidyverse to pull down some census blocks and counties for our study area. TriMet serves the tri-county area, thus the name. And that's Multnomah, Clackamas, and Washington County in Oregon. And the first tool I'm going to use is that TidyTransit package in order to start looking at just taking a snapshot of service and the network of TriMet in those 2 years. And it's really great. They have these great functions that kind of fold everything that you need into it. I'm going to read those zip files inside of each of those is a bunch of text files with those join keys. GTFS as SF spatializes it. And then it does something called SetServicePattern, which when you get into this is important to start to understand that like you can't exactly copy and paste this sort of analysis across all transit agencies and expect it to work, because different transit agencies, at the end of the day, the person who's making the GTFS is not the person who's setting the schedule. Transit schedulers have been usually at transit agencies for like decades, and they're not the ones who do this. So, but this is a visualization of the different schedules, which are these alphanumeric names up there. And what I want to know is typical weekday service. And I want to pick the right schedule in order to do that, in order to conduct that analysis. And so this one over here, this CCB schedule, which looks like it's on all the weekdays for Q3 in 2023 or 2019, sorry, is the one that I want to go with. I could do the same thing for 2023, but as you'll notice, like things change at transit agencies, especially now that a lot of them are making cuts. Their service schedules are changing and shifting around. So now I've got to pick another one. And long story short, I realized I had to pick 2 actually in order to get both bus and light rail schedules in this analysis, which wasn't the case in 2019. Don't know why. I'll have to reach out and actually talk to somebody there. But then let's just do a real simple sort of summary of service in the Portland metro region. I want to see frequent stops using GTFS data and TidyTransit. And for that, I can take a start time and an end time and basically calculate the average frequency at each transit stop throughout that day and filter that and get this, which is a map of all the frequent stops in the service area, 2019 on the left and 2023 on the right. As you can see, it looks like they added like a whole new frequent route along from Beaverton down to Tigard and Tualatin. Interesting. But then, you know, they've actually, as you look closer, you can start to see some frequent stops have went away, like along Division. A bunch of different routes got consolidated into a BRT line. And so they've removed a bunch of those stops along Division. And so now we don't have those. We can do a simple count and see that, okay, interesting, 2023 here on the bottom, the share of frequent stops actually went up, but the total nominal number went down. What does this mean? What does this mean for us? We'll get into that later. But anyway, TidyTransit, it's great for building an inventory, just kind of making a static map of service, summaries, and doing some quick summaries. But some caveats that you need to know is that GTFS is just like a vibe, kind of. It's frameworks. Transit agencies have their own business and their own way of dealing with things. And they'll try to put it into GTFS format as best they can. But at the end of the day, there's going to be a lot of curves in the road. So there's many exceptions. And so building knowledge and reaching out to transit staff is pretty essential. And then also frequency kind of depends on context. I did all day frequency. What if it was like just for the afternoon or just for the morning? The results would change. So in order to make sense of that and get some use out of it, let's start pulling in some amenities data. I'm going to use the leader package to pull jobs from the census API. It's a great package. I'm going to get school point data directly from our regional government's ArcGIS server. And then pharmacies, I'm going to use that OSM package to ping the OpenStreetMap APIs. You can see I'm looping through each of the counties here. And I'm saying, please fetch me the amenities with the value of pharmacy. Basically, I'm doing this because the API is going to stop any request that was going to return too many features. They don't want you to choke their very popular API. And so I've commented it out because I saved it as an RDS the first time I ran this, and I'm just going to read that in. And here's what you can get. You can get all the pharmacy points in the Portland metro region. But I want to do something a little bit more normalized. So I'm going to build an amenity grid. I'm going to start counting pharmacies and jobs and schools into hex cells that I've created using the SF package. As you can see here, this one, that yellow one, my cursor and the pop-up are different, but there it is. Quite a few jobs. There's 10,000 jobs in that hex cell, some number of schools, some number of pharmacies. So now that I have this normalized grid, let's bring in R5R. R5R stands for Rapid Realistic Routing on Real World Reimagined Networks. It eats GTFS and OSM street network data and produces routing and analytics. And you can model any sort of mode trip that you might want, or walking parameters. Say, I only want to walk 5 minutes. You can model that trip. Some alternatives are OpenTrip Planner and OTPR. This is the functions that set it up. And I'm setting my parameters. I'm going to do midweek in June and model walking and transit use. And then I can test it. Okay, so there's getting from Hollywood District to St. John's in 2019 versus 2023. I used to have to take the MAX and then transfer downtown and take a bus. Now I can just take one bus. Interesting. Okay, but then let's start to bring in the amenities. And for that, R5R can build me a matrix. I can route from each one of those grid cells to every other one and get a matrix with the travel time attached between those 2 points. And I can start to sum up, okay, now that I know the length from this hex to this hex, how many parcels or how many jobs and pharmacies are in that one? And, or how long can I get? Or how far can I get from where I live, which is this real little red hex there in 2019 versus 2023. Here's an isochrone using those grid cells. You might have seen something like this before. But you can see 2023, it's kind of like looking a little bit shriveled, a little bit anemic. Let's do a comparison matrix. Here we can see both transit schedules and kind of see how they diverge. The red cells mean it takes me longer to get there in 2023 than it did in 2019 by 17 minutes for this one. But I can get down to Tualatin and Tigard faster, which maybe is important to me if I was a different person, but I'm not. So, and now we can start to, okay, now that we know travel time between those 2 years from every point to every other point, let's see what that means in terms of jobs. And we start to do these sorts of analyses that you might see in other types of transit analysis, where blue line is the cumulative number of jobs I can get to in 2019, where I can get up to 25% of the region's job, or sorry, up to 20% of the region's jobs within 25 minutes from my house, because I live pretty close to central area. Pharmacies, and as you can see, 2019 used to get me a little bit closer to more pharmacies, jobs, and schools, and 2023 has been a bit of a decrease. But why don't we total those up? What does that actually mean for someone like me or anyone else? You know, I could pick a different hex and do the same sort of thing. I've lost 8 pharmacies, 18 schools, and about 20,000 jobs because of these transit cuts and rearrangements and realignments. You know, where does that land me? I can put myself at that line and I could do the range of every other hex cell using the same looping method and using those matrices, and see that I'm pretty good on jobs. I'm so-so on pharmacies, and in schools, I'm pretty good, actually. I'm at the top of the pack. So, you know, this is just a taste of OSM and R5R analysis. You can do dynamic trip routing. It's good at measuring usefulness based on OD, location, time of day, a bunch of different variables. It's great for comparing transit usefulness over time and really get into the meaning of transit service. But the caveats are, you know, it kind of backgrounds all those GTFS quirks. You could not know a lot of those weird things that are going on in the background if you were just going in with R5R. And also OSM, you were limited by OSM and, you know, who's updated the data and is it recent? That street network data is pretty integral to this sort of analysis. So big metro areas, it'll probably be fine, but smaller rural areas, kind of iffy. And there's no easy way to create your own new kind of manipulated conceptual schedules yet, but hopefully somebody's working on it. Thank you.